Okay, now we're going to look at the sine rule of trigonometry. Now for this question, we're going to have an isosceles an equilateral triangle ABC, where all the sides are acute, like all the angles. This angle is acute. Acute, I think, means below 90. This is acute. This is acute, and we've circumscribed a circle around this triangle, and the radius of this circle is r. So this is the radius. So this is r, this is r, the radius of this circle. But when you look at, this is the triangle we have. Now when you look at, the initial triangle we had is A, B, C, but now you see here we've drafted out a smaller triangle here, triangle BOC. But when you look at triangle BOC, this is the radius, because this is the point from the center to this side. Also, this is the radius. So, and the radius is equal, so the radius is r. So the radius actually, sorry, before you, so you should look, this is the sine rule. A out of sine A is equals to, so the question says show that in any triangle ABC, this is equals to that, this is also equals to r. So this is our triangle. Now when you look at this smaller triangle BOC, this is actually going to be an isosceles triangle. Why? Because when you look at this triangle, you see that these two sides are equal, triangle BOC. Another thing I've forgotten to talk about is that if this is triangle ABC, then the side opposite angle capital C is small c. The side opposite angle B, this is B. Then the side opposite angle A is small a. So this is what we have now. Since this is an isosceles triangle BOC, if this line a perpendicular comes dividing this into two, this is going to be A out of 2. And also this side is going to be A out of 2. So now we are going to do triangle BOC here, then we continue with this question. Okay, now here we are. So we've extracted triangle BOC, and you should know that this is not angle B and this is not angle C. Why? Because when you look at this triangle, we've just gotten out part of angle B. I hope this makes sense. Like this is the angle. This is the angle we have for B, and this is the angle we have for C. It's not the entire angle. And now here we have BOC. We had already noted that the radius was side BO, and also the radius is side CO. Then we had also noted that this side was A out of 2 and this side was A out of 2. Now, to find angle BOC, like this angle here, we are going to use it the first circle. We are going to find it using the first circle property, and the first circle property states that the angle at the center is twice the angle at the circumference. So it states that the angle at the center is twice the angle at the circumference. This is what the first circle property states. So what does this mean? So this means angle BOC, because angle BOC is the angle at the center here for this triangle, is going to be twice the angle at the circumference, and in this case it's angle, so it's going to be twice angle BAC. So we're obtaining this from the first circle property. I hope this makes sense. So what does that mean? That means that this angle here, what here up, it's 2A, because we've said the angle at the circumference is twice the angle. The angle at the center is twice the angle at the circumference. So here it's going to be 2A, meaning this is A, this is A. Hope this makes sense. Now we are going to extract out maybe triangle. Let's extract out triangle B, and this is point D. Triangle B or D. So this is 90. This is A out of 2. This is R. So we can get sine A, because here we've said this is A. So sine A is going to be opposite. The opposite is A out of 2. divide by the hypotenuse, which is r. So this divide by r. So sine A is going to be equals to, sine A is going to be equals to, actually here for this question, we're going to take the r, we're going to cross the r to the other side. So this is going to be r sine A is going to be equals to A out of 2. Then we're trying to make it a subject. So here we get A is equals to 2r sine A. So we divide through by sine A, divide through by sine A, because when you look at our question, it had is equals to 2r. So meaning 2r has to be made the subject. So here we get 2r is equals to A out of sine A. Now, exactly what we've done here, we're going to do it for all the other angles. Like we're going to redraw this circle, redraw this triangle. But for that, for the next question, we'll consider this triangle, this section, like the other triangle, we'll consider it. Okay. So I'm just going to do this same thing and I display for us to just go through. Okay, so we were at 2r is equals to A out of sine A. So now we go on to, and here we're working at on angle A, so that's why we do this here. But when we're working on angle B, we will do this here. When working on angle C, we will do this here. So let's look at that. So in this case, we are looking at angle B. That's why you see we drew this opposite angle B. And since this is the center, this is the radius. Also, this is a radius. That's why you see this is R. This is also R. And then this is B, this side is B, small b. This is C, this side is small c. This is A, this side is small a. And now since here we formed an isosceles triangle, if we drop a perpendicular, this side has to be equal to this side. So we divide this into 2. So this is B out of 2, this is B out of 2. Now when we extract triangle AOC, this is what we have here, triangle AOC. And now remember that we had talked about the circle property. We said that the angle at the center is twice the angle at its circumference. So if this is B, this is going to be 2B. So it's going to be B and B. So that's how we get this B and B. Now we extract any of these triangles, but actually for this, we extract any of these triangles, but for this, it's actually really obvious because even if you don't extract, you can see this is angle B, and you get the sine of B. It's going to be opposite, which is B out of 2 out of R. So when you take R inside, you get R sine B. That you also take that 2, then you make 2R the subject. So you have this. Remember in the first, we had gotten to R is equals to A out of sine A. Here we have 2R is equals to B out of sine B. Then here we have, for this question, this is one to find the one for C. We draw this opposite C. So we do the same thing. Since this is the center, this is the radius, this is the radius. And we know that if this is an isosceles triangle, that means two sides are equal and we drop a perpendicular from here. This side is equal to this side. So if this is C, this is C out of 2, C out of 2. So we extract triangle AOB. But remember the rule, the circle property, we've talked about that the angle at the center is twice the angle at the circumference. So if this is C, this is 2C, but we divide it into both sides, C and C. So for this case, I chose not to extract the triangle because you can actually see it from here. Because if this is C, sine is going to be opposite out of hypotenuse. So C out of 2 divided by R, and I also get 2R is equals to C out of sine C. But remember, the first time we got 2R is equals to A out of sine A, 2R is equals to B out of sine C. Now we have 2R is equals to C out of sine C. So we can just equate them, and just like that, we've proved the sine rule of trigonometry. So if a question asks you prove that A out of sine A out of is equals to B out of sine B is equal to C out of sine C, that's actually how you prove the sine rule of trigonometry, and you can use it to solve very many different triangles depending on what has been given. So we looked at the cosine rule. Now we have seen the sine rule. So we can look at the tangent rule, proving the tangent rule of trigonometry.